Hi guys, this video is going to be a little bit about multiplying larger numbers. The goal is to show you a little bit so that folks can kind of solve this. This is something you're definitely going to see on some of our assessments this year. 3 digits on top, 2 digits on the bottom. And so if you're really struggling with multiplication, you got to work up to get there. So let me just start off at the beginning. If I ask you what 3 times 4 is, the easiest way to know it is sort of know your math facts. And I know that sounds, obvious, but if you know 3 times 4 right away is 12, that's obviously going to help you. If you don't, then we got to use a couple of resources. Either we can come to a multiplication chart and say, all right, 3 over, I'm going to come down until I find 4 across, and that's 12. So that's always there for you. And then you can also look at it as like 3 groups of 4 or 4 groups of 3. Some people like to draw an array, 3 by 4, and then fill it in, and then count up the dots. And you can do that even with, an 8 times 9 or something like that. It takes a lot of time, but you can do it. And then some people just will skip count, and they'll say, all right, I have 3 4s. So 4, 8, 12. There's a million ways to do this. But you need to be consistent and have a way that always works for you. So I don't think people are going to have a struggle with that. They can do any of these methods. But where people start to struggle is something like 23 times 4. The biggest reason is, when I come over here, I don't see any 23s. And so this is where the standard algorithm will come in to help us. Whenever you do this, you think about adding or subtracting, you always start with the ones place. And so what I do, and really, let's break this down actually. This 23, it's harder to look at it and say 23, but what if I said 20 times 4, right? And then 3 times 4, because this 23 is a 20 and a 3. So if I find both of these, I'm going to be good to go. And so let me do that really quick. 3 times 4 is, we just found it was 12. And now 20 times 4, I want you to remember this trick. Nobody knows their 20s. Nobody knows their 50s. What they do know is the sort of root, the front number, in this case the 2. So I'll hide the 0 and I'll say, all right, 2 times 4. Do I know that? Sure I do. That's 8. And so as you hide the 0, the trick is, all right, do your 2 times 4 and now bring the 0 back. So I'll just put a 0 at the end, and that's 80. Well, if I add 80 and 12, I'm going to get 92. So our standard algorithm, what we do is we do the same thing, except we do it in this format. We say, all right, I'm going to take this 4, and the first thing I'm going to multiply by is the other ones right above it. And you're going to go least to smallest, or least to largest every time. So what was 4 times 3? We just found out that it was 12. But I don't want to write down 12 ones. Think about regrouping where 10 of those ones can turn into a 10. So what I'll do is I'll say 12, 2 ones, and I'm going to carry 1 10 over. I'm leaving this 1 10, and I'm going to add it afterwards, just like adding. So now I'm going to look at 4 times my next larger digit, which is 4 times 2. And it's very similar to this 8 here that we found earlier, except instead of stopping at 8, I have to remember I carried a 1 over. So I have to add that now. So what is 8 plus 1? 9. Notice you're getting the same answer. All right? I want to escalate even more here. Let's try out 23 times 54. Okay, so notice we keep the 4, the 3, and the 2 from earlier, but we're adding a 5 in the tens place. And at first this can get really hectic, but I kind of want you to think of the same thing. We already know what the 4 times 23 is. And after we do that, we're actually going to do this 5 times 23. But remember, this isn't a 5, it's 50. And the trick with anything that ends with a 0 is to hide that 0 and then bring it back. So off to the side, actually what I'll do is I'll always start here in this ones place, and I'll say, all right, multiply you first, 12, so put the 2 down there, carry a 1, and then 4 times 2 is 8, and I have that 1 added, so I have 92. Now instead of doing this row right here, what I want to do is come off to the side and just say, all right, what is 23 times 50? Because really that's what's going to come here. And what do I do when I do that? I don't do 50, I hide the 0 and I do 23 times 5. So let me do that for you really quick. 23 times 5, okay? And we know that that's going to be 5 times 3 is 15. So I can't put it all down here. It's 1 per column, 1 digit per column. So I carry a 1. And then 5 times 2 is 10, plus the 1 is 11. So at this point, I will put a 1 there and I try to carry it, and I say, oh, I can't carry it. and then put that right there. So that's 115. Now, since it's 23 times 50, well, what do? I took away a 0 to do this, so all I'm going to do is add a 0 at the end. And so I can shortcut it and say, well, this is going to be 1150, right? So one thing that happens with the standard algorithm is they say, let's shortcut it. Instead of taking away the 0 and then putting it back at the end, when you do this digit here at the bottom, you add a 0 right away, okay? And then you'll say, all right, now I'm going to go from this 5 to the smallest digit, all right? And so that's going to be 5 times 3. Well, what is that? Again, it's 15, so I'll put a 5 here, and then you have to line these up. This only works if you put them directly stacked over each other. So it was 15, so I'm going to have a 5 there, and I'm going to carry a 1. Now, sometimes if you have multiple things here, I might cross out my previous number and then put a 1. In this case, it wouldn't have mattered, but people do get confused by the earlier carryovers. So I had 15. Now I'm at 5 times 2, right? I went there to the ones, and I'm going to do the next largest digit. 5 times 2, 10. But I'm going to carry that 1 again. So I've got 11. So now I'm carefully going to write 11 here. And now the thing is, what I'm going to do now is add those two numbers, and I should have my final product. 2 plus 0, 2. 9 plus 5, 14. So I'll put a 4 here and then carry a 1. 1 plus 1, 2. And then 1 left over is 1. So 23 times 54 gave me 1,242, okay? And I think everybody should reflect on, what is the step here as you do it? Like, could you do this? If not, why? Could you already do this? Or if not, why? What's causing you struggles? Really identify that and rewatch the video and kind of listen for my explanation. So I come down to my final number here, and this is a big one, but this is the sort of stuff we're seeing. And I say, oh man, what am I going to do? And I've got this handy multiplication chart too. These were smaller numbers. I think we mostly have those. But down here, 9, 6s, and 8s, ugh. So for us, we still have our multiplication chart. You're not always going to have that, but for today, we'll use that. So my first thing I'm going to do is start off with this digit. Use this as my anchor. Okay, I'm going to multiply here, here, and here. Okay, 1s, 10s, 100s. And then I will add a 0 here because I'm doing 40. And I'll go 1s, 10s, 100s again. So let's see, 6 times 9. I'm struggling. 6, and I'll come down until I see the 9 here. Oh, that's right there. So that's 54. I'll put my 4 here, and I have to carry the 5. Always carry them in the order that it's written. 5 tens really. It needs to go over above the tens column. Now I'm going to say 6 times 8, 40. Well, I know that math fact, but in case you're not sure, 8 and 6 is 48. So I'm going to put my 8 here. Oh, slow down. 6 times 8 was 48, but I'm forgetting. I've got to add that 5. So off to the side, I might say, what's 48 plus 5? That's going to be 53. All right, so I'm going to write my 3 here and carry the 5, that 5. All right, go slow. 6 times 5, my last one with the 6. 6 times 5 is 30, and then add that 5, 35. So very carefully, I'll write this in. And now I'm finished with multiplying. If I off to the side did 589 times 6, sure enough, I'd get 3,534. So now that I'm done with this digit, I'm going to come over to the tens place. And it's like, okay, I'm going to start, but wait a second. It's not 4, it's 40. So to make sure I don't make this, I don't mess this up, I put a 0 in here now. That way I don't have to come back through and add it up later. If you think about it, if I waited till later, I would put in all these numbers here, and then I'd put a 0 here. And I'd have to rewrite it to try to stack it up the right way. So that's why they call this a standard algorithm. They've been using this for a long time. But I really want you to understand why we do different things here. So now I might even come through and I'm going to cross out the earlier digits. I don't need those. They'll confuse me. They are earlier carryovers. I'll say, all right, 4 times 9. What is that? 4. I'll come down until I see a 9 across. There it is, 36. So a 6 here. And I'm going to carry, making sure I keep track. If I get absent-minded here, I'm going to mess up, no matter how good I am. So now 4 times 8, all right, 4 until I get to the 8, 32. But 32 plus 3, 32 plus 3 is 35, so put a 5 here. And then I'll put another 3. And then 4 times 5, we do know that that one's 20, and I'll add 3 more to that, and I've got 23. Now very carefully write those in, okay? And then I'm going to add these up. 4 plus 0, 4. 3 plus 6, 9. 5 plus 5, 10. Go slow, guys. Some of you really know this stuff already, but you go so fast you make a simple error. It looks like you don't. 3 plus 3 is 6, plus 1 is 7, and then my final digit is 2. So I just found 589 times 46 is 27,094. Okay? If you've got any questions, guys, you want to do a study session, please reach out to me. Hope this helps some people. Thank you.